Now let's take a look at carboxylic acids, and they are organic compounds that contain the carboxyl group, and the carboxyl group is COOH. And what does that look like? In this case, we have a carboxyl group, so that is a C double bonded to oxygen, and that also has a hydroxide group right here. So this whole thing right here is a carboxyl group. Now, it's very important to not mistake carboxylic acids for alcohols. A lot of students will see an OH group and assume that there's an alcohol present. If it's double bonded or bonded to a carbon that has a double bond to oxygen, we're dealing with a carboxyl group and a carboxylic acid. Now, carboxylic acids, they can be saturated hydrocarbons because the double bond is not between carbon atoms. This double bond is taking place and occurring between an oxygen and a carbon, and over here we could have a bunch of hydrocarbons here that are all single bonded, or a long carbon chain with single bonds. So it can be saturated. Properties of carboxylic acids: they are polar, and therefore they're soluble in water, and they have hydrogen bonding, and therefore will have higher boiling points. When we're naming our carboxylic acids, we're going to use the same steps as before. The first thing that we're going to do is identify the root by looking at the parent chain. And the parent chain must include this carboxyl group here, so the root must contain that. So when we write and identify our parent chain, there it is right there. And I see I have 1, 2, 3, 4, 5, 6. So since I have 6 right here, I have a hex root. Now I have to identify what the suffix is, and all carboxylic acids, they are ending with oic acid. So what I do down is, if I pretended this was just an alkane, it's hexane, what I do is I drop the E at the end of the ane and add oic acid. So this becomes hexanoic acid. So now that we have that identified, we move on to the prefixes. And in this case, we see that we have a methyl group attached right here. A methyl group is attached to the parent chain, and since it's a 1 carbon side chain, it's a methyl group. We have meth, add the YL ending, so now we have methyl hexanoic acid. Again, we need to identify where this methyl group is located. To do that, we're going to number the chain starting on the carbon in the carboxyl group. So make sure that you start your numbering over here. When we were looking at alkanes, we would try to have the side groups have the lowest number possible, but for carboxylic acids, it's very important that you start your numbering at the carboxyl group. So I'm going to start numbering right here, and that shows me that my side chain, the methyl group, is on carbon number 5. So what I'm going to do is write this as 5-methyl hexanoic acid.